Tanush.
So, ma'am,
Actually, I'm speaking here. Is it audio is not video is not audible? Is that audio is coming along with it?
yes, sir, it's coming along with it, sir.
Oh, I'm facing some problems, I guess so.
Okay, sir, I will just see what is it.
Just ensure. Yes, now we are getting some comments. Not audible actually.
So, here we go into the program. So, that's the audio issue is due to something else. So, we will be rectifying it. So, I request Dr. D. Kripagaran, sir, to welcome the guest lecture expert, Mr. Edison Tamilmani from Retech Solutions.
Yeah, good evening and warm welcome to all. I extend a warm welcome on behalf of St. Joseph's management and members of Triple department to all. It's my pleasure to introduce about our today's expert, Mr. Edison Tamilmani. He has completed his graduation in the discipline of mechanical engineering in AC Tech, Karaikudi, and done his master's in the engineering design department, IIT Chennai. After his graduation, he started working on laser cutting CNC machines in his own concern, Retech Solution Private Limited, and as a chief technical officer of Retech Solutions, now he is leading a team of engineers in to create some technological advancements in various engineering fields. I welcome sir. And at this moment, I want to
Thank you.
specify a quote that is Tirkural. Selvathul Chelvam, Sebicelvam, Achelvam, Selvathul Elam Talai. I think we have a physical lockdown only. Mentally, we are free now because we can avoid unnecessary tension, pressure, travel, etc. So mentally, we are relaxed now. So we can use this as a good. We can take it as a good opportunity to enhance our skills and knowledge through the guest lecture experts like today's lecture from Mr. Edison Tamilmani. And really it's a great service to society done by our today's expert. We have a lot of benefits out of this. Main primary benefit is we can enhance our knowledge, and we are well aware that industries are having new revolution, industry 4.0, and moving towards industry 5.0. The core component or main component of this industry 4.0 or 5.0 is robotics. So future industrial automation process will be completely based on robotics. So it's a good chance for us to enhance our skills towards the robotics, like experts from experts talk like today. Okay, I with this small quote, I convey my heartfelt thanks to our today's expert to do such a good service, and I thank all for your participation on this seminar. Now I hand over section to our today's expert. Thank you, sir. Thank you to all.
Yeah, thank you so much for the warm welcome. Dhanush, is it visible? Is everything okay?
Excuse me,
Yes,
sir.
sir. Everything was okay.
I request all the participants kindly mute your video and audio so that except the presenter, all are requested to mute your video and audio so that the presentation will be very clear. And at the end of section, we can clarify doubts. So in middle, if you have any doubts, please post on the chat box so that at the end of section, the expert will answer your queries. So I request all your kind cooperation. Thank you.
Thank you, sir. Thank you so much. Actually, very
Thanks a
done the
lot,
part
sir.
of mine also. Dhanush, is it okay?
Yes, sir. Yes, sir.
Yeah, it was okay with my video. It's fine. Actually, I'm interested to see the people over here. It's a great pleasure to be here. Actually, I'm not the expert at all. Just a 90s kid, so who done the masters just a couple of years back. But anyway, it's great to hear that at least from the great people over here. But the thing is, we will be discussing at least some more topics related to electrical actuators. At least at the field of electrical actuators, the need, at least in the need of actuators, I can convey it very clearly, I guess, because I experienced a lot more than anyone else over here, I guess so, because in the point of academia and after that the industry that we wanted to start, we faced some issues that we couldn't easily fix it. We need support from all you guys, like educational advancements that you guys can do will help us a lot in the future. But anyway, before going to start with the presentation and other things, just I want to check the energy level of the students who are sitting over here. I hope you all know the chat box, and just say hi at a single time. Just do that. I'm waiting for you. Hi. How many students are there? Young minds can drop the message. Hi. That's enough for me. Is it coming? Yeah, it's really good. Thanks, guys. Thank you. Thank you so much. The hello or hi's, we are sharing it with each other. So, yeah, it's really good to have. It's nice. Yeah, it's nice potential energy. So it's enough, I guess. Actually, I moved it to the other thing. Whoever dropped the message, I'm really thankful to you, because at least you saved that in the initial trial. I thought of asking that to the coordinators, but they were even didn't try that, so it's fine. It's a initial trials are really good. So what the thing is, please do not drop any more messages at least if it is necessary. So okay, fine. We can move on to the presentation today. Oh, sorry, I opened the wrong window. Hello, Dhanush.
Yes,
Is it
sir.
okay?
Yes, sir. You are to open the presentation thing, sir.
Yeah, it's just I opened the slide topic of the this thing, first slide.
Yes, sir.
Yeah, it's fine. Okay, fine. I will go with it. The title, actually, I have given the title, desperate need of electric actuators, because that is what we need. The title says a lot about the current situation. Actually, I am Edison Tamil Mani. Actually, he has a Professor Kripakaran has a really good intro to me, because anyway, that's fine. I will go with the overview of presentation. I will go through many things here. One is a quick intro, but rather it is not quick. I will come up with a brief bio of our what we have done in the last couple of years after my graduation and other things. But now after that, I will talk about the present technology oriented related to the current electrical actuator thing, like EVs and robotics and all. Then I will talk about the importance of the steps. These will be the main thing that I'm going to concentrate today a lot more. The remaining things are the motivational things, where you can find the electrical actuators, the machineries, and robotics. You might have heard already many things. Anyway, we have great challenges in that also, because we don't have a single BLDC motor company, or any good motor companies that are over here. So in India, at least, so there should be some difficulties, right? So otherwise, there will be many companies that we can see. There are some few. I would figure out some. So I listed down. After that, I will tell you the resources. At least with me knowledge cycle, I will share the resources that I had already having, because knowledge circle is always should increase the in diameter, right? So and then after that, I will go with the demo, short demo. It will be very, very short. So if you guys interested, we can arrange some other sessions if you want. It's like a tool called the FEM and MATLAB. How we can use MATLAB with the FEM to operate the FEM. So we can produce multiple around hundreds of designs. We can easily iterate through. So we can find one final best motor design, if you say. Then I will talk about something about the dream of mine today, maybe tomorrow for you. I will the quick intro. I already said this will not be quick. It will take some more time, but just grab your chairs, guys. Actually, if you for that, I will help you. Actually, I will give you throw some pics or there is some putty story of mine to just to motivate to hold on for the next 1 hour. Here it starts. Actually, I born in Vedaranyam, it's a southern coastal area. So many of you might heard of sometime. But I born in a very very normal family. I'm brought up as a normal kid. Actually, I have done my yearly studies and all in government aided schools. I have done a really good job at least at scoring in those ways. So I got some good rewards too. So you are not in front of a very bored person. I'm little bit of a study oriented guy. So I did well in the school days. After that, I went to college. I mean, I did my mechanical engineering already, as he said. I did my mechanical engineering in Aragappa College of Engineering. It's a government college. They added the government, even the name itself in nowadays. It's a really good college. Actually, I should definitely say that, because that is a great place, because you can have a lot of freedom over there, because the government colleges are you can get the freedom, right? Other than that, there are very really good and great potentials like professors, but you have to find a way to utilize them. But I didn't do that, but at the time I highly recommend to do that, at least in your locality. For the students, I'm just dropping this message. This is the profile that I have. What did I have done in the my BTech is I have really considered on the CAD modeling. So I was so crazy about it. So I did many models like 3D. You can say many other, you can categorize it many surface modeling or pod modeling, something like that. But I have excelled almost in many areas. So I mean, with many packages like SolidWorks and Actuators and other stuffs also. That is my BTech part. I did my mechanical engineering, but mechanical engineering nothing to do with only the modeling. Actually, modeling is a different thing. That is kind of art, but anyone can do. Mechanical engineering is a real mechanical engineering. I want to test it, so I went for the GATE exam and I scored it really well, because at least that naturally comes to me. At least I guess so. I put a lot of effort to there, but there are no accident, guys. Actually, if it's something comes to you, you have to use it for the great purpose. So I used the GATE exam and prepared really well, and placed in finally in the IIT Madras robotics lab. So this is a good picture, actually. This is a good picture, but this is a picture of KUKA KR5. It's an industrial robot. So I didn't do anything about or anything with this machine, with this robot, at least. But this image is catchy, so some of you may get interested. Some of you at least want to see. Actually, usually my professor says that show them first what they want to see. After that, tell them what you want to tell. So what I want to tell is a different thing, but I will come up with the next upcoming slides. But it will be interesting though. Do not worry about the crisis, guys. In the story, at least in the first 10 minutes, it will be interesting, at least. I feel I didn't do anything with the KR5. I did something with a very complex model. This dual arm. It's not, the picture itself says it's a complexity. Actually, it's a very complex.
Excuse me, sorry for interruption.
Yes.
So presentation is not visible, sir.
Oh, yeah. Thank you for saving me at least. Just wait. Am I connected with the real correct thing? Yeah.
So please give present now, sir.
You said everything's okay.
I said you are just talking, sir.
Oh, okay, fine. I thought because of that only I ensured many things because the words shouldn't be repeated. Anyway, it's good. Just wait.
Yeah, yes, sir. Now
Is
it's
it
visible.
okay now?
Yes, sir, visible, sir.
Danush, you are here for this only. Take care of it. At least
Sir,
thanks,
I
bro.
thought that you are just talking, sir.
Okay, anyway, it's cool. I went through the only initial slide. So these are the things I talk about the overview. You can have the at least have a look at these things. It's a quick intro. I already said this is a reward that I got for my school days. And after that, I went to the college and I did some CAD models over there. This image may be interesting. The image shown over here, it's a KUKA KFI. Already I mentioned that. The thing over here, it is, yeah, it is a dual arm. It is, the picture may be complicated. Even it is actually the mathematical model of it is rather still more complicated than that because we have dozens of free parameters actually to design the model. Actually, if you there is something to called in mechanics forward and inverse kinematics, those problems are really difficult for this. Yeah, is it okay?
Sir, not visible, sir.
Still,
Yes, sir, it's visible, sir. Sir, please print sir's Edison sir's logo, sir. I mean, there will be a photo there. Please print it, and it will be visible now.
is that okay?
Yes, sir,
Yes,
it's visible, sir.
Oh, sure. Okay. Should I press this button? Your screen is still visible to others. Okay, fine.
Sir, please check. Yes, sir. Now it's visible, sir. Yes, sir.
Yeah, it's visible, right? I
Yes,
hope for all you guys actually. I don't want to repeat the things again. Just yeah, this was the picture. Yeah, here is the thing. I did my masters in this whole model. Actually, this model is so difficult. There are you can see the variables, count of variables. You can review more than easily 15 or more. So the inverse and forward kinematics of this system is rather difficult. So I have done that. We have optimized the design. Optimization is the technique that you can design. You can use it for to design the things. So whichever system it maybe you have to optimize in some way to get the parameters. If for simply if you say that if it's motor, then if it is a diameter of inner and outer things and poles and pairs, pole pairs and stator coils, these kind of things can be optimized with some using some optimization techniques. So we have done similar part of like this with this complicated system. So after adding the motors with the system, the whole system itself is collapsing actually. So why it is collapsing? There is a thing called a safe working zone. So people who are aware of it, the working zone is a zone that the manipulator end, this is called manipulator. So the manipulator end can reach without any problems. So without any problems, there are some kinematic singularities and link intersections. All the other steps are there. We didn't consider these motors as for the link intersections initially. So after that, we considered while we were in the stage of inserting the motors which are available in India, there is a very big headache because we have to design the whole motor. We have to over design it, otherwise the motors will not fix in the design. So we didn't do the manufacture prototype yet, but we just done this one mathematical part of it. I just got the degree. I produced some papers, so degrees comes with the papers, right? So, so fine. That is my college time. Actually, time I wanted to create some robots, so I wanted to build something in plastic because that are lightweight. So plastic moldings are out of range at the time. So even now, for us at least. So we thought of 3D printing. We built one machine on our own because we were interested in that time to make the machineries also. So we built one machine. We used open source software to run the machine. So that mission helped me a lot more in the upcoming things that I have done. One of the after my graduation, I wanted to do three things actually. One is the electric actuator, which will be a heart of robotics. Yeah, but we gave some attempts, but those attempts have much more potentials than I expected initially. So fine, I will show you the pictures, and the other one is the robots, and the other one is the machineries that already the 3D printer that we made that gave us some confidence. So to make some more CNC machines also. So just we went with the three things actually, in the motors, the robots, and the machineries. So what we did in the initially is we have found some scraps and magnets. So to check the proof of concept, it was working so well. So we gone through some more iterations. The 3D printer that we built, we made some more improvements also that we built. Actually, we built the only mechanical part. The electronics we just borrowed it from our neighboring country, China. Actually, no, so anyway, it's a great thing that at least initially we had the 3D printer. So we could able to iterate through many designs. It's a good part, right? When you don't know anything about it, just make some trials, get some idea what are the problems, then go for the physical design or otherwise mathematical models. Then only you can realize the stuff you want to do. You want to create fully. Then the same way I started with it, we had tried many more trials. It's in crude basis only. Yeah, at those time, I didn't even care about the what is the electrical part of it. Just we know the how to design a motor and how to actuate the motor, something like that. So we did baby step only that. But after some iterations, it all happened in the first month of my journey in 2017 or 18, something like that. So we have created some good models. We could able to do that. This is a 3D printed model only, but we pulled out the iron core from some other dynamo or something like that. So it was running really well. So for you guys, it was running more than also we have done the MOSFETs and the other things also on our own, because to get a hands-on idea, you had to create something, then see what are the problems in the problem. There were many problems in the motors because we didn't design it. We just used the core randomly available with us. So we designed the motor based on the cores available with us at least at the time. So in this one, that's the bearing initial models that didn't have the bearing also. So the thing is, yeah, this one, you might able to figure out what is the problem is. This is a material called ABS. People who are aware of 3D printing may aware of it. What is the melting point of it? It's around more than 230 or something like that, 230 degrees Celsius. After that only it will melt. But you can see the core, at least the plastic material near the core, how it is melt. Yeah, it is melt actually. So I thought of thing in this way. Actually, at this point of time, I stopped everything, every baby stuff we did so far. This is working. If you give the current, it is working. If you want to increase the speed, if you increase the voltage, yeah, the other thing we could be able to control, but we didn't design it from scratch. But that initial trial, it was so successful because we have done what we have to done for the initial trials. So we got some ideas, but now the essential part is coming. You have to design it from the scratch, and you have to know how many turns you have to wind, and how many what is the wire cards that you can use to and what is the maximum voltage that you can give to safely run this motor. What may the peak torque, something like that. There are many things in motor technology. Actually, people know much better, I guess. Okay, those things are there. So yeah, I stopped it because I didn't have those kind of background. Actually, I for the background I earned it from MIT Walter Levin lectures. It is electricity and magnetism. So I will talk about later because that is a good resource that you can have. Only that course is enough to this motor, and some more articles found in net is enough to create it in real time, because you know the things, how you can mind, how it is working, then you can create it. But this is not the optimized design. This is not even designed right. So it's just a experiment. The experiment is always, but there is no good or bad in the experiments. Experiments are always good. So we thought of the three things I said. Right, motors, it's on hold as of now at least. Then the robots, you cannot even balance in the torque density of the motors. Also, it's so less. A torque density is so less. Power density is there, but we don't have we don't equipped with the motors with the gearboxes. Gearboxes, even I'm a mechanical engineer, I don't like gearboxes because there are a lot of efficiency problem. So I don't like it because as a robotic engineer, gearbox is always adding the weight at all, because if you have a better design with a higher torque density, then you can design a better motor. Other is you don't have to worry about, at least at the point of time, if you have the electrical actuators, you can think about the robots. That's what we have decided, because this is one we cannot even think about the dynamics and control and the other things and all. This is a 4 degrees of freedom SCARA robot. We initially did some, again, the baby stuff. Okay. The next thing is Dhanush. Yeah. Hello, Dhanush.
Yes, sir. Yes, sir.
If something goes wrong, then let me know. I think your professors have my numbers also.
Yeah, sure, sir.
Just
Yeah,
I'm
sure.
going with the flow, right?
Yes, sir.
Just I make sure. Okay, fine. Yeah. The other thing that I wanted to tell you guys is many of the guys who are here, maybe students, I expect at least. The great professors also may be here, but they can share the story if they want to motivate the people who are interested to start their own startups after their studies, because that is the thing that is highly needed in India, even beyond the electric actuators. Startups should be there. If some startups are working on motors also, we don't have to worry about it, right? But don't ever expect some people come from sky and give you the electric motor, because no one is there, at least. This one actually, we did the 3D printer part, so we had some confidence to create the machineries. So we use the 3D printers. 3D printers we are not commercialized. We didn't commercialize, at least at this point, because it has its own problem, because you have to have at least small kind of awareness or how to run, and there are many things you have to tune it, and you need some more experience to do that. We were not in the level to reach them all, but anyway, this is the simple thing that we can do in the 2D. So we tried with the pen plotter. So in the same 3D printer itself, but this time it's a different thing, because we ran it with our own code. We used C++. We were good at the programming, at least programming and electronic stuff. So we did these parts on our own. So we created a tabletop model for this A4 size machine. Initially, we did, yeah.
They are saying that the presentation is too fast. So
Okay, I will. Sure. Thank you. Thank you. Where I was. It's good to have the feedbacks, at least real-time feedbacks. Yeah. Hello, Dhanush.
Yes, sir. Yes, sir.
Yeah, I was rushing because the time limit is so keen. So
yes, sir.
Yeah, is the words per second is a lot more, or otherwise what is that?
Yeah, yes, sir. Yes, sir. Words per second is a lot more.
Okay,
they are telling that please slow down.
Okay, fine. I'll slow it down.
Sure. Thanks a lot.
I thought the energy level of the students is much more than me. Okay, anyway. Just wait, guys. Actually, I will resume it from the, where I have dropped. Yeah, here it is. We have, now it is fine, I guess, at least to those who has issues. Here it is. Actually, that we have initially developed as a 3D printer. We used different things. Here you can see the motor over there. To make it as a CNC, we gave some trials also. We used pen also to create some pen plotters. Finally, which one, the laser module that you can see over here, it worked really well, because we can easily, this is weightless. This is a diode-based laser, so it is it's efficient also. You can create up to 3 watt power, so you can do some wonderful stuff. So with the same machine, in our point, we were developing our softwares and multiplying our machines. At least some cash flow were there. At the point of time, we moved to some new place. So this was a really good thing. We sold around 100 people, 100 missionaries so far in the small one. Yeah, here is a mission, that the first successful mission that we have delivered, because we have some more attempts that are put on hold. Already I mentioned you in the robots and the motors and all. Yeah, the after that, improvement should be there. Otherwise, people will not like the company, right? So we were doing some really cool things. We were manufacturing bigger missions, and we did almost. This time we were so keen about manufacturing our own things, even these screws and springs and all. Even those kind of small things also we manufacture our own. These all are made custom. Mechanically, we were really good at that. At the same point of time, we were really good at the software part too, because those things we don't have to worry about the current, how can you say, the environmental situations, right? Because you don't have the semiconductors, or you don't have the touch screen. The touch screen over here, it is imported from China, but the software in so it's kind of thing. Whatever we have, we did our part really well. We know the limitations. If you want to try everything from the scratch, definitely you will be in the middle of the ocean. So you will not get any directions. If all the things over here, if you want to develop from the scratch in the laser tube and display, even say, that is hell. You should not do that if you want to create a startup, because whatever things you can really do or you can really optimize, you do that and excel in it. After the time comes, then you can do other things. The motors also we are getting from Pune. Anyway, there is a route to China also. Yeah, this is some of the wonderful things that those machines can produce. There's a laser cutting of acrylic parts. So Dhanush, interrupt me anytime at any time, because if I'm running so fast, but note down the comments too, because I'm not noting it down anything else. I hope everything goes well.
Yes, sir.
Okay, fine. Yeah, here are some of the cool stuffs. Actually, at least it's cool to me, because we have done this mission, created this mission from scratch, at least most of the part. So it was received so well in the community too, because there was at least at the point of time, the only Chinese mission were there in not it was like last April 2019 April we launched this mission in a product expo in Chennai Trade Center. So again, I'm rushing, it seems like, so I will slow it down. Yeah, it was received so well, the missionaries. So we multiplied those missionaries. Each mission will cost you more than around 1.6 lakhs or some that. So if someone is spending that much of amount, people are our customers. The first one is Anna University CG campus. They supported us a lot with the 2 missions they purchased it from us, the same kind of mission. So this is a mission. If somebody buying it for 2 lakhs, around 2 lakhs, then they will expect the same kind of the level of advancements, right? So at least somewhat we fulfilled all of those guys' needs. So here it is in the market. These are the 2 products. It's basically missionaries, laser-based missionaries. We have it in the market. It is successfully running. I'm really happy to share all these things to you. Almost my brief bio is ending. The last thing that it's not least thing, but see that it's Delta robot. This is a robotics, right? Robotics always whenever we can do that, we will try make an attempt. And this is a Delta robot. The kinematics may be difficult, but that is none to us, because I'm really good at that, because I learned from the people who really does that well. This is a Delta robot, but here also there is a part called electrical actuation. So mechanical and the kinematics and the safe working zone and the control of it, it's really easy. At least to me, at least those things were familiar. The electrical actuators, we have to buy it from China. Each of those actuators, if you add the closed loop control also, it will cost you more than 15K. Each motors will 15K, means then it will add up easy. It needs a gearbox too. So otherwise you cannot have the torque record to move the machine. So it's a great difficult thing. That is the greatest limitation that we have with the robotics, at least in India, at least in this current situation. So okay, fine, these are cool. Okay, I'll stop it here with whatever we have in the last 2-3 years. People who are really interested in startups, take care of the things which are available to you and what you can do really better than the others. So fine, that is the message that I want to deliver. The next thing is yeah, hereafter we can slow it down. The brief for you, because people should not get bored, right? Even in this crisis time, people should not get bored. So because of that, I rushed a lot more. And this is current trends about. We can talk about that. Many of you people heard of Tesla or Elon Musk say. Elon Musk always at least said in a video that I had seen, being extraordinary is an option. You can always choose to be an extraordinary person. Ordinary people can be chosen to be an extraordinary person. So I greatly believe in that concept. Actually, yeah, but whatever the concepts that you, if there is a need for electrical actuators, you can easily create it. I will motivate some of the points which are the current trends that they can use through that. Okay, permanent magnet motors, you people may aware of it. There are two kinds, basically the AC DC you can say, but fundamentally if they are using the permanent magnets or not, that is what the matter is all about. If it is basically based on the induction, the rotation is happening, then it is a different kind of scenario. There may be some slip. The other kind of machineries are synchronous motors. We can skip the part of DC motor, brushed DC motors, because none of the great people worry about the brushed DC, because that's gone, and the time for is a brushless DC either, or otherwise PMSM, or the induction motors. Tesla always concentrate on the induction motors. At least the name says that Tesla there should be some induction. So this is the current version of the PMSM, I hope. This is a really difficult thing to say, this motors, because you have to check for the backend profiles and current profiles, what how they are doing, because BLDC and PMSMs are can have the same mechanical structure. So we call it as PMSM, at least for the sake of clarity here. It's a permanent magnet synchronous motor. So this motor shown here is used in Model 3 and Model Y. These are the current models, some of the current models of Tesla. I hope most of the people aware of the Tesla. I am talking about an electric vehicle company called Tesla. So I hope everyone knows. If you don't know anything about Tesla or Elon Musk, it's better to have an idea about what these great people do, because they are the trendsetters. So take a minute after this presentation, just check about Tesla. Yeah, those guys did these things. This is the motor. That is the rotor of the PMSM motor. This is Audi. They used a permanent magnet rotor and stator with the coils. So these kind of motors nowadays in the electric vehicles are using. So what is so great about it? They are using rotors with the magnets, right? Permanent magnets. So you don't have to. There is a lot of small things that you can improve with the permanent magnets. The one thing is slip. You can easily overcome it. The other thing is the weight reduction. You can easily do it. Yeah. And those are the EV guys. Those are doing a really great job. Comes to the this one, robotic technology. Actually, in the last decade or otherwise last 5 years, the people were so crazy about to making this robots called the 4-legged robots. It's our quadrupeds in technical term. So this is one of the video that I can share it with you all. It's not my voice actually. It's there in the video. The one over here roaming around, it is called MIT. Yeah, MIT Cheetah. This is the mini cheetah. This one. So this is a robot that I'm so really interested about, because the guy who created this robot is a really good guy, because he shared everything online. So that is a great resource that people can have, at least in this time. because of this guy, I came into getting some confidence that we can do some stuffs to optimize the motors, and we can do some motor design and all. Here, the robot has 12 actuators. 12 of them are BLDCs, or otherwise PMSMs if you use a filter control, AC wave, something like that. So it's a PMSM. Take it only thing. BLDC, synonymally, I'm using it as a PMSMs also, because you don't know the current profile, the working profiles of the robo motors, say. So each leg has 3 motors. 2 are for the planar actuation, 1 is for the out of plane actuations. So this robot does a really good thing. But what is the point? Why do we have to create these kind of robots? I will talk about it a little later. But before that, there is one more current trend of creating robots with actuators. Yeah, it was published published only for you guys, I guess. There is a company. Yeah, I just need the image, not the. Yeah, I just need the image. Actually, there's a company called Agility Robots. It's coming from the good university, I guess. I guess it's UPenn or otherwise some good university only. It's from US. It's creating really good things. It's partnered with Ford Automotive. Now they are making some good progress. Actually, the motors are again here it is the very important thing, because it should not have much more weight. So the motor design should be optimized really well. This robot, so what is, there are many other humanoid robots also. What is so special about it is it has almost same form factor of our humans, so it will fit really well in all kind of situations. So I was so really interested about it. So there are some really good things, good progress there these people are making. Who knows, even after 10 years or something like that, these robots may be in our houses also, because technology already, the decades and technologies are the timeline. If you say each decade has its own technology developments. If I take us 90s or 80s, it was a personal computers, so it developed a lot better in that time. After that, 90s and 2000, that time frame, internet has developed a lot better. After that, smartphones came into the last decade. So these kind of things, as a 90s kid, I didn't even think of having a phone in my early 15 years. So because at the time, even the tsunami, those kind of time that I'm talking about, it was around 2004. Even we didn't have a TV in our houses. So we cannot say that which will happen in the future, right? We cannot predict. At least people who are willing to create the future technology can predict it at least. I am a follower of those guys. These are some of the good guys that you can even check about it. This video is published in 1 or 2 days back, maybe yesterday, I guess. I don't know. Okay, fine. That was a very recent video. They were really making some good stuffs with the electric actuators in the heart. EVs are there, robotics are there. So there is some good point, right? If you need some more, how can I say, the reasons to develop the motors also, I can deliver some, at least in the point of a common man in this country. The first one is the Rafale, and the second one is the MiG-29, the first two. These are the aircraft that we are buying from other countries. At least some of the guys from some of the people, because we have great professors also here. Some of the people may aware of it really well, because we are buying these machines for much more of our GSTs. So what is the point? Actually, we should not buy an apple with a diamond, right? Actually, a diamond is so costly, but we don't have anything else. We have the diamonds. We need the apples, the real apple I'm thinking about. We have to get it because they have a greater responsibility. I'm not coming into the politics, right? I'm just telling the truth. In the current situation, they have the great responsibility to protect the nation, and our people cannot make it really well, so we rely on the other people, and we are paying a lot more than it costs actually. Yeah, There are some other failure products also of our nation, and that is not our nation, the MG. But anyway, we in these fields actually we have almost we faced some failures so far. So it is a great how can I say, the responsibility of the current upcoming students to have why you are developing, what you can do with your education. So it is a really good thing to have a better education, to create some cool stuffs which will help the nation all together. So there are some motivation, guys. So you just have it, at least at this point. We can see what else we can do. If the one more thing, this is a good thing to see. Comes from the Boston Dynamics. It's again the company from US. If these kind of robots are coming to the market or otherwise coming to the military, our country will be the first one to in the line to buy those robots for our military, because we need better production, but we have money from the agriculture and other things. So what we are exporting to other countries, you might aware of it. It's like a milk product or something like that. We are not selling or exporting any these kind of things. Actually, we do some good things over household items because they are using even the washing machine that I have shown here. All these images are, there are no image credits. All those images are grabbed from internet randomly. I'm using the word random so randomly. So neglect the part. This is a random pic that I found from internet. It's a really good thing because these people are doing some manufacturing over here of BLDC motors or otherwise the motors, whatever the motor they use. So these are the coming to the scope. There are a lot of the scope that is there with the motors, but we don't have the motors, so we are importing either the motor. We are not importing the motor because it's a really difficult thing, right? So we are importing either the whole machineries here, or otherwise we are either allowing the companies who have the technology to develop it to manufacture it here. That is not the real development. If we people do not know anything about the tech behind it, it's not even if you have a many more automobile companies over here, it's really difficult thing to have a startup doing real good things in the automobile field. Actually, we had one from our lab, Ether. There is a company called Ether Energy. They were really good at producing electrical motors in this nation. So they are now currently based on Bangalore, and now they are in Chennai. Actually, it's my I'm proudly saying that I come from the same place where they come from. Okay, it's cool. Anyway, there are many other things also there, guys. Actually, the motors, the missionaries already motivated some via my story itself, because we will not stop it there itself. We are producing the laser machines. We will keep on producing some other cool stuffs, 3D printing, which will be incorporate all the modern technology, and metal 3D printing, we are thinking of it, the laser cutting, metal laser cutting, and the other CNC works. That is the streamline that already we had, but we can, I hope we can have some good progress over the years, because these are the machines somewhat less dependent on the motors, but the robots are not that way. Robots are really majorly based on the motors and the drives. So here is a guy, he is a robotics, actually the stream of robotics, but here is I'm going to talk about a guy. He is his name is Benjamin Katz. Actually, he's really good at developing motors. Even he is a creator of this whole robot, if you say. He did a major portion of it, and even he submitted papers out of it. What this robot can do, you can see it. If any of you guys missed it, just I'm showing this. This is called yeah, MIT Cheetah. This robot, actually, the lot of the resources design this robot is it's available online, and it is free. So you guys, if you want to make the same thing, you can even do it. At least the sources I will mention in the upcoming slides. So there is a really good thing, because these can be really used in many other fields in India, in surveillance or otherwise rescue operations and all. So it's good to have at least a view of this. But they have really good point of views. The industrial robots, already I talked about the Delta and the Scara, otherwise the Kuka KFA I showed initially. or the robots which are meant for specific purposes, those will be go into the industries in the coming years. But as of now, we have a lot of human resources, so we don't worry about it a lot more. But we have to think about these things a lot more than the industrial robots, because this will go into can go into everyone's house also, and also in the military also, military too. Okay, fine. I'm leaving this robotics part. I think I had enough. Okay, there is some more interesting, really good stuff when the next decade is going to see. At least I hope before 2050s, definitely we'll have the vehicles kind of this. Actually, what are the necessary or important thing that for this these kind of vehicles are this? In fact, the title says eVTOL. eVTOL in the sense it's a electric vertical takeoff and landing mission. This is called it's basically vertical takeoff and landing. That's it, guys. You can have the all know about the quadcopters and all. It's same kind of tech. They use the same kind of flight controls and all, but they used a lot bigger batteries and bigger motors, the efficient motors, because you are flying, right? So the motors should not have carry more weight than truckers. At least it should be optimized in all the way it is possible. So the motors are the main contribution of these kind of vehicles. But I say, you guys, these will be the future. So if you are working for the current trends, actually, if you're working for an electric vehicle of which will run in the roads, then we may fail. Actually, because we have a lot of legendary companies working on the same field. In this, at least we cannot make better gear or better whatever brake systems or something like that. We cannot consider all things, right? Already automobile industry has are based on their own. So instead of going to the level, we can take a turn over there and we can bypass them with these kind of machines. At least I hope these can be done. But Elon Musk says that in some way it is a little difficult because with battery power density and all, we are not up to the level yet. But there are really good companies that are doing the great things. Yeah, it's all about the breaking the rules, right? So they were doing a really good job there. Yeah, Dhanush, is that any problem?
No, sir.
Okay, thank you. Yeah. This is flying vehicles of the future, because there are some really good companies doing the same stuff. This is an electric actuator in the heart. Actually, there are 36 actuators in this vehicle. They have the real-time prototypes also. They are quoting it as for 300 kilometer per hour. It's an insane speed, right? I can fly from here to my house in 1 hour if it is not COVID time. Okay, it's a really cool thing. If we have one here, we don't have to worry about it, because and this is electric also, the power efficiency will be there. So we have to create all these things, guys, that the future, at least we should have some crazy ideas or otherwise crazy motivations behind it to develop something more. So this is one of the things that I thought it's worth sharing. This is company called Lilium Jet. What they were aiming is a lot better. These all four posts over here are very recent. It is after COVID only. It's from 2013 to 2020 only. It is what these posts are saying is a really important thing. There is a company called Joby Aviation. Toyota invested a lot of money in that company, in the startup. They invested around $590 million. To give you an idea about the scale, it is around 4,500 crores. Yeah, I'm not wrong in this way. Actually, around 5,000 crores Indian money they are putting in the company. And here, if 240 of the money, it's around 3,000, I guess. 2,000, 2.5 anyway. Yeah, those kind of money they are putting in these kind of how can I say, the electric vehicle companies. These are also electric vehicles, right? It's not necessary to always we have to constrain with the 2D. We can go for the 3D also. If you open the 3-dimensional region, definitely we will have, there will not be, there are some safety issues already. These guys always concerning about, but there will not be any great issue, because we have 3-dimensional possibilities. We can have, if a path have some problem, then we can find another path in the other altitude. So it's not a big deal. So if you guys interested, then I listed out some of the cool companies and backed by some of the really good people. Actually, Larry Page or Tencent, PUBG guys know that. Toyota, we all know, Hyundai, we know. I mean, these are the companies who are really interested in the future tech, because if you are concentrating on the tech which will come in the future after 5 years or 10 years, then that company can easily survive. It can do a better job, because most of the people will, if you are creating missionaries, people will not get much interest, because already they are there. There are many missionaries. There are not cool stuffs going on. There are not cool. There are not many cool stuffs going around in the valves also, because there are almost these kind of stuffs are saturating the missionaries. We can invent something more with the 3D technology, but anyway, people may not get the interest in that field, at least in the initially, because if you are creating the same kind of missionaries over here, the laser missions already we developed. It's already there, because we had it for more than 10 years from China, but none of them really worked in the, none of them from India really worked in those missions. At least we did a good job. At least I hope in that way we motivates us a lot. So we have to create something which will be beneficial to many other people also. So for the mass industry, otherwise the product which can touch the people of millions of people, then we have to think about this kind of technology. It's not like a mobile. It's like a mobile, actually. It's not like some other thing that I mentioned. It's not like industrial robot also. It's, we can, if you have a humanoid robot which can serve as did an iRobot, then that is a different scenario that will rule the part, actually. But we don't have, I am an optimist, but I don't think that will come in 2050s. I will not, I guess so. Anyway, we will see. If those comes, then we have to step aside and welcome them. But we, who knows, we may be the creators of those humanoid robots which will come and rule the world in the future. But for those things, we have to get the stuff, really technical stuffs that is highly required for that, because there are a lot more things we have to learn about it. Yeah, here is the things, guys. eVTOLs, at least you might have got some overview of it. Many of you guys didn't aware of, many of you guys, I guess, didn't aware of it, but I hope at least I thrown some seeds over there. I like agricultural thing. Okay, fine. The challenges, yeah, coming to the part, actually these are the things that motivates us a lot to develop electric actuators. What are the challenges? Are we having any electric actuator company here? There is a company called JST Motors. Even our DRDO people who are creating robots for our nation, they are using, because they are constrained to use Indian manufactured products, because they cannot use other stuffs from. So they don't have the facility that we have. So they concerned with those, but we visited those company during my time in IIT. So even with the DRDO people, the thing was, it was so nice experience, but the motors wasn't so good, actually. I'm not criticizing, because I know the constraints of the startup which are developing something from scratch in India. I don't know, they have their own concerns. But it was really difficult, actually. The robot was not so working good. I showed one of the motors in my CAD model initially, and there are many things also. Why we are not making any good in that field? Because it's not so easy. It's I pretend to show you some this one equations, but without having Maxwell's equations, it's not complete, will not be complete. So I just thrown it over here. These are the 4 Maxwell's equations. You guys know it, I guess. So if you don't know it, you don't have to think about the electrical engineering, at least. At least you have to know these equations and the form itself.
Sir, the voice is not audible. Hello, sir. Vagadeshan A, sir. Vengadeshan, sir. You have muted the Edison sir's presentation. Can I know why?
Sir, it's, your audio is muted, sir.
Please wait. Please wait. I have to say certain things. Vengadeshan. Sir, please wait a second, sir. Sir, the audio is muted.
Yeah, now can you?
Yeah, yes, sir. Wait for a second, sir. I need
Sure.
Mr.
Yeah.
Vengadesan A, I need to talk to you. Please. Why did you mute the sir's presentation?
Leave it aside. If you don't want to remove those people, if you want.
Yeah, sure, sir. You can continue, sir. Thanks a
Yeah,
lot.
yeah, skip it. No issues actually. May I know when did it happen? Is it happened just now or is?
Just a few seconds back, sir.
Yeah, that's fine. Anyway, cool stuff. Yeah, I really wanted to motivate you guys, but I don't know if something is really went wrong. That is fine. But anyway, yeah, we should have some experience, guys. At least these kind of experiences. This is my first webinar that I'm going to give. Actually, I accepted only as the first time because I don't usually the guy like academia. I don't like teaching also. But that is a great profession that needs a lot more energy to put in. So fine. Anyway, but my interested topics I never miss to teach to some other people who are really interested in that field. That is the same point that motivates me to be here and sharing my things with you. Yeah, it's good to have. Anyway, moving on. Yeah, there are many difficult things that you can think of. One is the mathematics behind the motor technology, because this is electromagnetism, right? So it is really difficult. The field equations you can easily solve it in closed form and something like that. So you have to rely on some finite element models or something like that. So I will of the tools that we don't have to solve these equations fully. Actually, we can use some finite element analysis tools to develop some models. I initially resisted myself to use those tools because I thought that should be some other easy way to do that by using these equations. I gone through the fundamentals, which my master from MIT did that. Okay, but that didn't work out so well. So at that point of time, initially we put the project of the product electric motor and hold. Now it's a time to resume it. I hope so. So it's a good thing. The awareness, you have to get the awareness. Otherwise, you will not. You will easily get directed to some other things. Also, there are cool stuffs like programming, and you can easily get placed in those fields and all. So there you can find their own problems. But anyway, electrical engineers is not meant for those kind of jobs. But electrical engineers should do some real electrical stuff. One more thing, I am not an electrical engineer, I am a mechanical engineer, but I love engineering in the whole. Yeah, I have my own restrictions or resistance beyond my control also sometimes, but anyway, it never resisted me to take it again and give it a shot again. But this is my second attempt in this COVID time. Some of you guys may have the interest to get these things, so they can easily figure out a way to contact me, or otherwise we can schedule a series of webinars if you want to move on the tools that we can use to design electric actuators. In future, we can see how the things will work out. Anyway, you should have at least some awareness. Talk to people who are having these kind of things. Otherwise, talk to your professors or something like that. So it will be helpful, guys. So don't forget to do that. Because they may have a lot more than what you think they have. So it's better to talk with the professors and at least the people who are really interested in those fields. They may not have the opportunity to work in the same field because any one of us having their own difficulties and restrictions and all. So it's better to have how can I say, person or otherwise as a mentor in this field to get motivated and to work on the same thing, even if you are not producing any good results in that field. Should have the awareness what are the tools used in, what are the ways you have to approach, and what are the resources available also. Create some awareness even among the people also, and more importantly, the awareness need taken care of is the thing. Actually, you are meant for something. Actually, you are not going. You don't do any baby steps in TCS or Infosys or something like that. Those are great companies. They have giving the lot more opportunities to a lot of the human potential over in here in this nation. But you people are really meant to do a lot more than doing the normal stuff. So realize your potential. That's what I can say, at least at this point. You have some really, you can have some really good tools also. I will talk about some tools about this. There are some few tools called Ansys Maxwell and Motorsol, FEM, and there are some other tools also, more tools also. Why I'm throwing these things is Ansys most of the people may know that this is familiar with the finite element analysis. We people from mechanical engineering really know this stuff. And the other thing, the third one is familiar, maybe familiar with the academia, because that is so familiar in the all around the world. That is a free and open source lightweight package called FEM, finite element method and magnetic, something like that. So that is a really crazy software, because I didn't think 8 MB 8 megabyte software can do a great stuff like electromagnetic analysis. So it does it very quickly also. So it is a really good thing you can start with. And where I grabbed is grab these things is, or the I mentioned you, right, the MIT cheetah robot. The guy who created that robot is Benjamin Katz. He has the greatest potential because he was investing his around more than 6 or 7 years in his PhD in this work, I guess. So whether I'm exaggerating or not, I don't know. But anyway, he has invested a lot of time, because you can see it really from those blog posts that he had in his own websites. Now he is in Boston Dynamics because he wouldn't have any other option better than Boston Dynamics. He did his own motor design with using FEM and MATLAB. He did optimizations and all. He shared everything online. The resources are available. Only thing that is, as Elon Musk says, you have to choose. You have to choose to be an extraordinary person, even you are ordinary if you think so. And yeah, I will show you some resources that I mentioned thing. I mentioned the thing, right? Ben Gatz. Here is a profile of him. Here you can find not only the motor design, you have the you can have the resources of motor drives and all. So it is a really how can I say? It's a really good thing to have, at least to visit once this profile, and what is the done, what is the things he has done so far. So it's a great resource, so you can have. And other things now, to grab the background and all, you can have professors like Walter Lewin, and yeah, there are many other video series also, but those are not so complete. If you want the electromagnetics, electricity and magnetism, in the sense, I couldn't find any best resource than Walter Lewin does as this point of view, because he's a great professor. Yeah, it's a really good thing. There is a how can I say that, the playlist in YouTube called Electricity and Magnetism by Walter Lewin. Here is a professor. You might know his face because this is somewhat familiar in the academia. He's so the other thing is, you can grab some really good books here. And then this is overpriced a lot more now, but this is a really good book that I could found initially. I didn't open this book for last 1.5 years, but now I have the time, so I don't have any other opportunity to start studying on it. It's a really very good book, at least in my point. So this is a good thing you can take a look at. And the other resources that you can grab is your in the control part, or otherwise in the drive part. You can use MATLABs. They MATLAB. It's not only the how can I say, the software company which is selling softwares, but they are promoting a lot of technology also online. They have a lot of videos online. They were good people teaching the things. They will be short. They may be difficult in the first time, because that is meant not only for you, it's for the world. So it may be in different level than you are in, but you can get up to the level also if you start following on them. There are some good resources. Even today I am following all those, not all those, some of those from YouTube. You can find YouTube channels of MATLAB and what they do, the BLDC motors, and they have some really good stuff also. They posted everything with the codes and other things also. You can find the codes in GitHub. It's a really good part. MATLAB, you guys may have the familiarity also. While coming to the, you can grab the basic things with this, but have some how can I say, really some good tools also to do all these things. FEM is one of the thing. FEM, you cannot easily find some good resources online, because I don't know the reason. And generally motor design, if you talk about, then it is really difficult to find a good complete online tutorial series, because even I have searched for the same question, but even before me, many people did the same raise the same question for our other forums also, but none of them could be able to give a satisfactory answer. So we don't have one specified electric motor course, design course yet. But I hope some of the institutes, like there are many other institutes we have NPTEL and other things also, but none of the courses exactly specifically concentrating on this stuff, electric actuator as a whole thing. So we can find some bits of pieces over there, but it's difficult to find a complete course over there. Anyway, we will see. Yeah, FEM, I will drop some resources in the chat box if you want. Otherwise, some other way I will do that, because coordinators know that very well than me. So yeah, coming to the drives, where are we? Actually, we have resources, right? We have to talk about the resources. Yes. What are the resources that I was posting here? So these are the resources. Some you can easily found, or otherwise you can easily easily get the names. This is one of the things. It is called better. It's kind of what is the thing called? ESC. ESC, I hope you guys know it than me. It's electronic speed control, I guess so. Because okay, fine. Anyway, leave the part. It is a speed controller. It's not only the speed controller. I don't know why the word comes as a yes. Okay. It does many other things also. Really good good thing. Just wait. I am getting call from Professor. Hello, Professor Chipas is here. Hello. Hello, sir. Is there any problem? Oh, okay. I thought I got a missed call from you. Okay, thank you. Okay, thank you. Actually, I think it's better to have a better section a little bit, because it's already 10, 6, 12. Okay, I'm almost at the end of the thing. There are one last thing that I can show is a demo. These are some of the good things that you can have look at it, because those are the people from University of California, or some other really good people have this citations. Why I'm saying this is these are not the simple things that people have done. So these are valid things. You can have a look at it if you want to create some drives and all. And have some experience hands-on, do some bursting with the MOSFETs, and you will be an engineer soon. Yeah, here comes a short demo. It should be a very short, because already we are running out of time. So the thing shown over here is, one is a MATLAB window, the another is a FEM. The result produced in FEM is how can I say, it's coming from the script that I wrote in this one, in this MATLAB. So MATLAB, if you say a comment, then FEM will follow it. So there is an integration. So you can have some resources also for that. It's really hard to find the complete resource for this, but anyway, I can easily drop the file that I have used for this demo. Yeah, I'm going to the demo. Just for that, I need one more system. This is not my PC actually. I have my own PC there. I hope you guys are with me. Just wait. Yeah. Now I am in another window of mine. There you can see something. This is a Mathematica tool called Mathematica. There you can use symbolic computations easily. So it's a really good tool. You people, if you, some of the people interested, you can take a look at software called Mathematica. And you have MATLAB also. You are familiar, you may be familiar with this kind of tools. So I just did some. These things are easy to me because already I grown up in the same field only. So to create a graphical thing via parameter design is not a difficult thing. At least I had the background of from the CAD and also the programming these kind of environments. So it was so easy. So I grabbed it in the last 15 days only. These kind of stuff to how to generate a whole thing in MATLAB, whole motor in the geometry in the MATLAB in FEM. There is a tool called FEM. Yeah, this is the tool. This is a very lightweight package. What you can do is you can do some stuffs like basic electromagnetic analysis of different motors, and you can even if you want to have an idea, just create some basic shape and just wait. I will give you a quick demo if you want. Just I'm creating a new one here. Just I'm saving it as a test. Yeah, you have to create the geometry first. After that, this is for the guys who want to hear something technically. So this tool just I'm introducing, or otherwise just enhancing a little bit if you are already aware of it. Yeah. Never mind these steps, guys. These are so easy steps that you should do in every cases. You should have some materials to apply with. In this case, just I'm going to add only the magnet. Yeah, I have added two materials because I have only two regions over here. The outer region is the air, and this is a magnet. This is a crazy shape, but I don't have to worry about it. Just follow me with the procedures. You are creating the geometry. You have to apply the nodal parameters and all. Yeah, this thing is air. Then there are another parameter that we have to worry about it. The other one is called magnet. So it should have some direction also. I'm giving a 90 degree. So it's up. It's computed from the horizontal x-axis. So counterclockwise also. That I have to mention. Yeah, then you are done, guys. That's it. You have the results over here. Yeah, these are the flex density that map that we can have. This is called this legend shows us it's around one Tesla over here. If it is there are some critical things you have to consider about this plot and with the motor design. I will show you some also if you want to. Just wait for yeah, this is one complex design if you say, because I did everything each one I just did that manually. assigning the parameters or circuit parameters and magnets and the regional parameters and all. So it may be time-taking process, but to create one design, so you can have the results also. Just wait. Here's a geometry. I have created this geometry from using CAD tools like SolidWorks or SolidWorks. I did it. I imported this one as a DXF. I will show you in a minute how to do that. If you are already familiar with CAD tools, otherwise some whichever tool you are aware. Yeah, is that any problem? Hello. Yeah, I hope it's good. Okay. We can have the plots also. Yeah, in this plot, one thing you have to notice is that yeah, here is the thing. Here is the thing. Actually, the tooth cannot be very small. Also, if it is very small, the thickness of the tooth is very small, then it is a really difficult thing because the magnetic field density over there it is going more beyond the 1.5, 1.6. It's not highly recommended. So it's better to keep the design or otherwise status the iron core's magnetic field, maximum magnetic field less than 1.6 Tesla. That is a notable thing you can notice in this, but at the same time you can see the field lines, how it is moving around, but this is a different difficult how can I say, this different category of the machine that I have simulated just for my consideration. So all the magnetic poles are in the same direction, so you can see the field lines coming around, and it's not how can you say, it's not, there is a term called flex linkage, so it's not linking with the another adjacent magnet. So there are some things you can easily get some idea about. To have a basic experience, you just go with the basic things that you can do with the FEM initially. To do that, I can drop which one, the DXF file also, if you want to practice. So it has a 4-pole. You can import thing over here, DXF. Yeah, here it is. This is a 4-pole 6-slot motor, BLDC motor. Yeah, this one you can apply the materials. Just I created a geometry from SolidWorks, so I can share it with you guys, so you can have experience with it. I have some little resources also. You can apply the materials and the region and the current circuits and all. So that you can find the torque and all. You can easily the tool is easily giving the torque and other things, the integral part of it. So what is the point? We cannot how we can design. If we have the geometry, we can analyze it here, but design is not that, right? It's the inverse process. So you have the requirements, you have the torque requirements, and you have the speed requirements and all. So with those things, you have to get down with the parameters. Actually, you need to find out the parameters. What is the tooth thickness, what is the radius, this radius, and what is the radius of the outer radius of the stator and the rotor. These kind of geometrical parameters you have to find out. That is all that is the process called the design, right? Design process. So how we can do that? We can use some optimization techniques to do that, but that optimization technique will iterate through many more parameter space. It's kind of, it will be generating around 100 motors at a time. So it will analyze all those things. It will take the parameters whichever is whichever parameters gives good results. So it will move on that direction, and it will give you the better results at the end. So hopefully we have to do that to design it better. But for that we have to do some, we need some better scripting tools. Here is a script that I wrote. I will share it with you guys. Yeah, here is the same procedures. You have to create the geometry. Just initially I'm running it with the, if you run these things, these things will be, actually the FEM is opening because you evaluated the command like open FEM. So the project is defined. And the other thing is, this is a little geometrical. If you know the trigonometry, that is enough to design, at least to design the not the design, at least model the geometry. Yeah, I'm right. Here you can have the I'm running this section also because I need those parameters. Here it is generated, right? It's at the, you may not believe it because it's from here only, guys. So I will change it. I didn't open it earlier, so yeah, I just ran it wholly, so it will go through all the process. This is what you can generate. Actually, this is the whole process is done. I thought of giving you a step-by-step demo, but anyway, we will keep it aside. We can create some animations also out of it. How it is? Is that any problem? Yeah, this is the animation. This is the animation created from MATLAB script only, the same script. I just commented it out. You can generate all these images and you can compile those images to get an idea about it. This is only giving the talking talk. It's not giving the final talk because I didn't even model this one on the current circuits and all. So you guys can easily do that. There are very few steps only. You can easily grab it and get some idea about. It will not take you more than 1 month to excel all these things that I'm going to talk about. I talked about. Yeah, that's how I'm finishing that in that way. That is easy. I will show you if you need a lot more, but I'm switching it to wait. Yeah, my presentation now. This is the thing that we have seen so far. So what is the thing? Yeah, here is the part, right? Here is actually the whole webinar takes place because of I asked Professor Kribakaran sir to give me some interns to work in the motor field because I was working. I just restarted the thing for the last couple of months. So I thought of doing the stuff. So I thought it's better to have some more people also to work in the same field. It will be good and interesting because the success you can share, it will be motivating at least. So I asked him, so he said, give us a webinar and tell us what you want and what are the things that going to our interns can do. So I thought of agreeing. So agreeing the thing called webinar. So I didn't even give a webinar before, or only the college seminars I had. But anyway, it's a good experience. At least I gone through in the last 10 days because after that only I grabbed all those things and did some part here. Yeah, hello. Is that fine?
Sorry for the interruption, sir.
Yeah.
Please turn off your microphones. Sir.
Is it fine? I'm almost at the end.
Yeah, okay, sir. Kribakaran sir.
Yeah, okay. It's anyway, we can accept it from the grade. Okay, yeah. The thing is, this 2020, we thought of 2020 will in different manner, but it's happening this way because the last year we were gradually coming up as a self-sustaining company, but this year we are celebrating the 100 days lockdown. Our people couldn't even work from their home, so it's a really critical thing. So already it's 100 days are gone. So I thought of not wasting the time. So I could able to share some thoughts of motor design with you guys. So I hope I motivated some of the parts that I came through to design a better thing for the future. So if you guys can think about it, just think about it and share it with the people who aren't really interested in that. If you don't have, yeah, we can see how these things can work out, and the final thing will be the motor design that we have to have our own motor and drive system as soon as possible. So I need some more soldiers because we cannot win the war without the soldiers. So you guys are the soldiers. You have the enough potential that you has to have. So that's almost I have done my part, I guess. So there is a saying in our language, right? Yeah, that, you all might know that. I'm spelling it out. Katradhu kaiyalavainum sorry, கற்றது கையளவு கல்லாதது உலகளவு. This is a negative statement. So not negative, but this is a truth actually. We cannot even have a full knowledge even if you come beyond after around 1,000 years also time, if you do the time travel and go into the future also, the same statement holds, because we cannot have the full knowledge about the universe. That is so great, always will be great. So the thing is, it's somewhat negative statement, but anyway it is interesting. But I thought of writing it in my own way. Here is one of mine. So this is it, guys. So you can have my contact details if you want to have, if you are really interested in having some to be an intern with me or otherwise to work with me. I'm just inviting you all people who are students, professors. I'm just heartily welcoming you to be my how can I say, it's not a marketer actually. I just convey this point to the to students, so we can have a better community to work with the better future. Yeah, thank you so much, guys. Thank you so much, professors and all the other peoples also.
Thanks a lot, sir. Thanks a lot for your valuable webinar. There are a lot of things to get ready and things to be learned. So can we have 5 minutes for a Q&A session?
Yeah, sure. We can have. Even I'm also interested in that.
Yeah, sure.
But valid questions are allowed, guys.
Yeah, thanks a lot, sir. So any questions regarding the webinar? So you can proceed in chat box. So please don't turn on the microphones.
So there's one question from Satya Kannan. What are the benefits of using an electric actuator system over hydraulics?
Over hydraulics, yeah, it's a good thing, but it's a complicated question. At least to the knowledge circle of mine at this point. Yeah, what I can say. Hydraulics is there, but none of them are using our hydraulic systems in the systems that I talked about. You can have hydraulic systems for how can I say, the prismatic things, but not for the rotary kind of stuff. Can I say that it's we can deal about it little later. Personally, if it is worthwhile, I will share. I will ask them to. I will come with a better answer for that, because I don't have it now.
Okay, sir. There's another question from Satya Kannan.
Sure.
What advancements in electric actuation have improved current processes?
What advancements in electric
actuation have improved current processes?
Yeah, the one thing I mentioned in our in the talk also, the thing hallback array, that is how can I say, the best solution the people can come up with, the people from physics department also. So these kind of stuffs they put in the permanent magnets, the rotor design. The Tesla has a PMSM. I have showed in, some of you people may know that Tesla motors, Model 3 motor, specifically I'm talking about it, that has a more power density. That is the main advance tech, right? So it has their own advantages also, beyond the other companies, that the rivals that they have. Yeah.
Okay, so then Krishna Prasad has asked, which is better, LabVIEW or MATLAB for control of motors? So unmute, kindly unmute, sir.
Yeah, sure.
Which is better, LabVIEW or MATLAB for control of motors?
I'm not the control person yet, so I cannot comment on it yet. But in my point, MATLAB, many people were using even in my lab, so I thought it is really good. So lab, I don't have any other comments, because I don't have comments because I don't know it. Yeah.
That's all about the questions, sir.
Yeah, thank you very much.
So thank you for enlightening us with your knowledge. Thank you so much, sir.
Thank you so much, guys. Thank you so much, people. Great people. Yeah.
Thanks a lot, sir. Thanks a lot again from St.Joseph Institute of Technology and Department of Electrical and Electronics Engineering. So thanks a lot for handling this session, sir. And it's a privilege to have you as a guest lecture expert for enlightening our.
Thank you so much.
Enlightening our faculty and students. Thanks a lot.
Sure. Thank you so much.
Yes, Dhanush.
Yeah,
Dhanush?
yes, sir.
Yeah. I thank a lot for the today's informative session. I thank resource and I appreciate the audience patience listening, and I thank them a lot for the kind cooperation. Finally, I want to appreciate my faculty members, especially faculty coordinators Kavita Madam, Sifa Sir, and student coordinator Dhanush. Arrangement. Really, it's a great job they have done. I thank a lot my staff and student coordinators for towards this webinar. And in fact, student coordinator Dhanush is organizing a series of webinars for the past 2 months. Really, I want to appreciate him top all for his great effort. In fact, it is a great service to the department and the college. Thanks, madam. Kavita, madam. Thanks, Sipa, sir. Thanks,
you, sir.
Dhanush.
Thank you, sir.
Thanks a lot, sir. Thanks a lot.
Thank you, sir.
Shall we close
Thanks,
up? Dhanush, what about feedback
Yeah.
form?
Yes,
Sir,
sir.
feedback
Feedback
has
has
been
been
published,
published,
sir.
sir.
Yes, please.
Thank you, sir.
So, any other queries regarding the webinar? Or just we will be just closing the session by now.
So